Hey guys, so in this video we're going to be talking about the limits of trigonometric functions. So let's get started. So here we have that the properties of the previous limits apply to the trigonometric limits. And what I mean by that is that the properties that we learned before, such as the addition rule, subtraction rule, and quotient and multiplication rule, they all apply to trig limits. Now, when we're talking about trig limits, we're going to have this little box here of trig identities that we're going to use, but let's not talk about them now until we actually need them. And there's two important limits that we need to remember, and that is that the limit as x approaches 0 of sine of x over x is equal to 1. See, if you try to input 0 into this limit, you'll get sine of 0, which is 0, and then on the bottom you get 0, which is a problem because we can't have 0 on the bottom. But through some theorems and some proofs that the professors like to do and show off in class, you magically get 1. So we don't actually need to prove this ever in class. We just need to remember that sine of x over x as x approaches 0 is just 1. Alright, which kind of breaks the whole rule of having a discontinuity in the bottom of a 0. So now we're going to talk about our next rule, which is the limit as x approaches 0 of 1 minus cosine of x over x. So once again, if we plug in 0 into the bottom, we're going to get 0 in the bottom, which is a problem. But somehow, through some math, we're going to be able to get that it's not undefined, that it's actually going to be 0. So we get a finite answer for both of these using the rules that we have to just memorize. So I'm actually going to do something which I'm going to call it a proof, but your professor may not call it a proof because it doesn't take 3 hours, it's not boring, and I don't use letters in every corner. I'm just going to use simple math manipulation that we're going to use on how to get this identity right here using this identity right here. So we're going to do just that. We're going to use the properties of limits that we have learned before, and we're going to use the identity of sine of x over x to prove that 1 minus cosine of x over x as the limit of x approaches 0 is actually 0. And let's start off doing that. So when we look at it, like I discussed over here, if I were to find the limit, right, the first thing I need to do is input x equal to 0. But you guys already saw that when I input x equal to 0 here, I get 0 on the bottom. That becomes a problem because I cannot have 0 on the bottom. So then whenever I have a problem, I need to manipulate. And in order to manipulate this problem, what I'm going to do is I'm going to look at the problem and be like, okay, I have 1 minus cosine of x and I have 1 over x. What can I manipulate? So before, the manipulation rules that we have learned were conjugation and factoring. So there isn't anything here that I can factor because there is no x squared or x or anything to any other degree other than 1. It's just everything's linear. And then we have conjugation. How can we use conjugation in this problem? Those are the only two techniques that we've gone over on how to manipulate limits, and we obviously can't use factoring because there's nothing to factor. So we could probably conjugate, but the question is, what can we conjugate? And that is where these identities right here come in, right? So in these identities, if you guys notice, everything is a trig function squared. So I have sine squared, I have cosine squared, tangent squared, everything's squared. But here, I don't have it squared. I just have cosine to the first power. So what I'm going to do is first, I'm going to create a conjugation to square this, right? So the conjugation that I'm going to use, or not the conjugation, I don't know if that's a word, the conjugate that I'm going to use, it's going to be 1 minus cosine of x over x, and I'm going to multiply by the conjugate of 1 minus cosine of x, right? And the conjugate of 1 minus cosine of x is, we're just going to switch the middle term, so it's going to be a plus in the middle, right? So it's going to be 1 plus cosine of x, and since we multiplied it by the conjugate to the top, we need to also multiply it by the conjugate on the bottom. And now we're going to do some boring old distribution, or like some people like to call it, we're going to call it foiling. So we're going to distribute here 1 times 1, so we get 1. 1 times positive cosine, so we get positive cosine of x. Negative cosine times 1, so we get negative cosine of x. And now we have negative cosine times positive cosine, so that's negative cosine squared. Okay? So now we're going to rewrite the bottom. Remember that we only distribute or FOIL, whatever you like to call it, the one that you're conjugating. You never actually deal with the bottom, you just leave it the way it is, and you guys will see why in a second. Okay? So now we're going to collect like terms in the top. So here we have a positive cosine with a negative cosine, which are actually going to cancel. And now we're going to rewrite this as, we just have 1 minus cosine squared, and the bottom's going to stay the same, right? Just x times 1 plus cosine of x. So we're left with the 1 minus cosine squared, right? That's what we're left with. So what's another way to express 1 minus cosine squared? So if we go to our identities, right? So we go for help up here to our identities. Let's say we need to solve for 1 minus cosine squared. So the only way to do that is by moving over this cosine here to the right, and that would give us sine squared of x is equal to cosine squared, 1 minus cosine squared. So since we have found 1 minus cosine squared, and the representation of that is just sine squared of x, that's the equivalent of that, we're going to write that down here. We're going to have the limit as x goes to 0 of sine squared of x over x times 1 plus cosine of x, right? So far here what we've done is just a little bit of like a conjugate, some simplification, and now this is the part where we actually have to think about what we're going to do, right? So we need to think about what we're going to do. So the main goal when we're doing all these conjugations is to get rid of the problem, and the problem usually is going to be our x in the denominator, because if we have x in the denominator as we're going to 0, that means we have a 0 in the denominator, and we don't want that. So what we're going to do is we're going to try to get rid of this x. And how am I going to do that? Well, I'm going to use my identity right here that I have, that sine of x over x is equal to 1 as I'm approaching x equal to 0. Well, I actually need to break up this sine squared into two sines, sine of x and sine of x, in order to be able to use my identity, because there's no identity for sine squared. So I'm going to have sine of x times sine of x, and then this one's going to be over x, and this one's going to be over 1 plus cosine of x. Okay? So the last thing I'm going to do here is just break it up into two different limits because they're multiplying, you see that? So I'm going to break it up into two different limits where they're multiplying each other using the rules of limits that we can use on trigs. That's not a problem. So now what we do is we're going to use the properties, put that a little up, my head's in the way. So we can use the properties that we have here, this identity, this rule that we have, to let us know that this whole thing is going to equal 1. Okay? Because that's what it's equal to. It's equal to 1. And now, how are we going to solve the right side? We don't have a property for the right side, so we're going to go ahead and just input. So sine of 0 is going to be on the top, and there's going to be times sine of 0 over 1 plus cosine of 0. Right? Well, what's sine of 0? Sine of 0 is just 0, and 1 is just 1 plus, what is cosine of 0? Cosine of 0 is also 1. So we're going to have 0 over 2. So we're going to have 1 times 0 over 2, and what is that going to give us? Just 0, because anything times 0 is 0. So we have showed you guys how to go from here to 0, which is our final, to 0. Let's put that like in red or something so it stands out to us. We have gone from here to 0 using some manipulations and actually the identity here that we have learned. So I would say it's actually like a pretty challenging trigonometric limit to start off with, because there's a lot of stuff going on here. You're using your identity, you're also You're also moving stuff around. There's a lot of techniques. But I felt like it was the best way to just show you guys everything you guys have learned already from computing limits into applying it for trigs. So now we're going to do some slower examples, but they're going to include all these techniques. So I've exposed you guys to everything, and now we're just going to master it. All right? So let's go to example 1, where I just tell you to evaluate the limit. So when I mean evaluate, that's going to translate in your guys' mind to input. And then after we input, we're going to see from there if this is a nice limit or this is an ugly limit. So let's input 0. Okay, let's do so. 0 plus 1. And then here we have 0 squared times cosine of 0. So 0 squared is just 0. Cosine of 0 is just 1. 0 plus 1 is just 1. So here we have 0 times 1 over 1. So we have 0 over 1. And if we have any questions about whether this is 0 or this is undefined, we can always bring up the rules of 0 over a number tells us on, so it's going to be 0, or a number over 0 tells us no, so it's going to be undefined. So in this case, 0 over 1 is 0 over a number, so it's just going to give us 0. Okay? So now let's move on to example B. So here in example B, we're going to start off by inputting. So exactly what we're going to do. Cosine of pi over 2 plus 1 over sine of pi over 2. So let's say you guys just forgot what the unit circle looked like. It's been so long. You guys should at least remember that pi over 2 is here. It's 90 degrees. And the coordinates of one unit up at pi over 2 is going to be 0 for the x and 1 for the y. Okay? So I chose an example where you didn't have to memorize the whole unit circle for this. You just have to, know like the basic ones of 0, pi over 2, pi, 3 pi over 2, and 2 pi. So just chose pi over 2. It's a pretty classic angle. And we're going to say that the cosine of pi over 2 here, the cosine of pi over 2 is equal to 0 plus 1. And now the sine of pi over 2, which is the y value, is 1. So this is going to be 1 over 1. So our answer is going to be 1. So here in the top, I gave you guys nice limits. Nice trig limits. Nothing to really worry about. But now, in part C, we'll see how I'm going to change that up just a little bit. So here in part C, we're going to start off by inputting. So if I input 0, I'm going to get 0 on the bottom, and that's already good enough for me to know that I need to manipulate. But let's put this on the top anyway. 2 times 0, which is sine of 0. And sine of 0 is equal to 0. And we have a 0 on the bottom. So that's a big red flag that we just need to manipulate. Okay? So now we're going to try to use our rules. So here's the problem. In our rules up here, we have that it's sine of x over x equal to 1. So let's actually copy our rule down here, so we're not scrolling from top to bottom. Let's copy our rule down here. So what the problem is that here I'm supposed to have the same thing in the angle in the denominator, right? So it's x over x. But here I have 2x over x. So how am I going to make the angle, which is inside of the parentheses, and the denominator the same? I need a 2 here, right? That's what I need. But how am I going to do that? I'm just going to multiply the bottom by 2, but in order to multiply the bottom by 2, I also need to multiply the top by 2. Okay? So now we're looking at this limit, right? So now that we've used our properties, we're looking now at this limit. Limit as x approaches 0 of 2 sine of 2x over 2x, right? So now we're good because these two match. But what am I going to do with this 2 right here? You guys remember? We talked about the constant property, which means that I'm just going to take out this 2 outside. So I'm going to have 2 outside, because it's just a constant. I can just take it out, times sine of 2x over 2x, right? So now this thing right here, this whole thing right here, since it's the same, the angle and the denominator, the whole thing is just going to turn into 1. and then I'm going to multiply it times the 2 outside, and that's just going to give me 2, right? So this is like what I would call a manipulation you need to do in order to get that. Now I'm going to give you guys a quick trick, like a quick little my own formula that it serves as like a checking system, right? So we're going to write it over here in green in this little corner, okay? And it's going to be at as the limit of x approaches 0. It's going to be just a mild arrangement. So it's like to check. You cannot use this to just, this is my answer. You actually need to do some work. Whatever, we're going to write the sine of ax over bx, okay? So a is the coefficient of x, and b is the coefficient of x in the denominator, and the answer is going to be a over b, okay? And what that means is that we look at the coefficient of x, and then we look at the coefficient of x in the angle, and then we look at the coefficient of x in the denominator, and then we just divide those two. So here, if we were to look at the original problem, the a in this case is 2, and the b in this case is going to be 1, right? So if we do a divided by b, it's going to be 2 divided by 1, which is our answer, which is 2. So that is why it's just a quick little trick, but you still need to go through the whole multiplication on the top or on the bottom in order to get the answer. All right? So this is just like Junior's custom little formula for you guys to be able to just check your work. Okay? So when you look at the problem, you already know it's 2, but you need to do the work to match it. Okay? And that may work sometimes. Sometimes it's good to know the answer, and then you just kind of forget a little step here and there. You're like, but the answer has to be 2. So you just kind of just go backwards. You just make the answer 2 somehow. You know? You might get lucky, and your professor may not notice that you didn't do the work right. But as long as you got the answer correct, that might give you some points at least. Okay? So let's go into letter D, where we have tangent. So far we've only seen a rule for sine, and we've seen a rule for cosine, but we have yet to see a rule for tangent. But guess what? When we have the limit as x approaches 0 of tangent of 5x, and we just plug it in, which is our first step, we're just going to get tangent of 5 times 0, and the tangent of 0, if you guys don't remember what the tangent of 0 is, you can just do this, right? Where's 0? 0 is right here, and the coordinates of 0 are 1, 0, right? And what is tangent? Tangent is equal to sine over cosine, right? So tangent of x is equal to sine over cosine. So what is the sine of 0? The sine of 0 is 0 over the cosine of 0, which is 1, right? So what does this give us? 0 over 1 spells out on. So on is just 0. So in this case, our answer is just 0. So if you were going to start manipulating already, you didn't have to, because what you do first is always just plug in 0. You plug in 0, and then you see what you get. And if you don't have a problem, like in this case, you just get 0, you're good to go. So now let's do some practice problems, and then we can do a lot of manipulations with trig identities. So let's get started.